All right, you guys. I'm so sorry for not getting videos out sooner. It's been a stressful last week and a half, but today I had a great epiphany and like I got really driven. I was like, I want to do more videos. I want to get a bunch out. So I'm gonna record a couple tonight and get them posted for you guys. I'm really excited to where this YouTube channel is gonna go, and with your guys' support, hopefully it'll take off and that more people can get enjoyment out of it. So without further ado, let's go ahead and get started. I want to do a video, which you already can tell from the description, Lewis structures, just drawing them and understanding them. So there's a set method or a stepwise method you can follow. I'm going to be inevitably following that method, but I'm not going to explicitly like define it. I'm just gonna I want you guys to see how I walk through them as opposed to, some method, because maybe it helps if just to see someone else walk through it with their what's going on through my mind while I'm doing this. So I want to start out real quick with an easy one just to get the concept down. So let's go ahead and start off with water, which is H2O. And so when the first thing you need to do when you're approached with Lewis structures is you have to find out what the valence electrons are. This is all based around valence electrons. So we know that if we look at our periodic table, that we have hydrogen is in the 1A column, and then starting over, we go to 2A column over here, and then 3A, 4A, 5A, 6A, 7A. The 1, the 2, the 3, the 4, the 5, the 6, the 7, oops, I don't know if you can see that. Those are the number of valence electrons. I always say that the periodic table holds all the answers if you know how to find them. So if your periodic table that you're looking at right now does not have this 1A, 2A, 3A, 4A, etc., it will have the 1, 2, 13, 14, 15, 16, 17 on it. It will have those. They always do. And you just look at the units placed. So the 3, the 4, the 5, the 6, the 7, those are the number of valence electrons. Notice 3, 13, and 3, 14, 4, right? So pretty easy to see that. So in our case, hydrogen contributes 1 valence electron, or has 1 valence electron, and oxygen has 6 valence electrons, right? So knowing that, we've got 2 hydrogens, so that's 2 electrons from the hydrogens plus 6 electrons from the water or oxygen. So that goes to 8 electrons total. So I'm going to go ahead then and start writing this out. Since I've got 2 hydrogens, I know that I'm not going to have 2 hydrogens bonded to each other directly, so that would mean that our oxygen has to be the central atom. Again, there's probably a nice method of determining what the central atom probably is, but think about it logically and be like, well, you wouldn't have, hydrogen, then oxygen. You're going to have probably that oxygen holding them together. So let's go ahead and draw that out then. And since we're drawing Lewis structures, it doesn't particularly matter at this moment because we don't know how the electrons are going to be distributed. So it doesn't matter at this moment how we draw them. So it's going to be linear. But for you chem nerds out there, you probably know instantly that it's a bent structure. But that doesn't matter. So I'm going to keep going. I want to keep this video short. So I've got 2 hydrogens bonded to this, and I've used up 1, 2, 3, 4 electrons. If you consider one of these bonds contains 2 electrons, so I like to just sometimes write those in, 2 little dots at the end of the bond to signify 2 electrons. So we've used up 4 electrons of the 8 that we have left, or that we had total. So we have 4 electrons left. So normally you would put them on the atoms bonded to the central atom, not the central atom. You always put your electrons on the stuff out first, and then last resort you put electrons on the central atom. But in this case, we can't put any electrons on the hydrogens because they just can't handle it. The hydrogen is too small. It's only a proton. It doesn't have enough balls to hold in all of those electrons. Okay, so it can't do it. Bottom line, don't ever put electrons on a hydrogen. It won't work. Not at all. So don't do that. So what we're going to do is we're going to put those last 4 electrons on the central atom. Like this. Right? So that is our Lewis structure. Now, you would think, well, I'm getting those electrons really far away from that oxygen. That's, that's good. This is not actually how it's orientated. But again, this is a 2D structure. So to convert this to a three-dimensional like structure on the page, if you imagine you're looking down at this water molecule from the top. So if we rotate it, like we take this and kind of rotate it back like this, you would actually end up getting something like this. Right? And this is a bent structure of how water actually is. These lone pairs are up here. And this is actually the electronic geometry. The electron domain geometry is actually tetrahedral. But the molecular geometry is bent. So the difference between electronic, or electron geometry, that's a G, versus molecular geometry is the molecular geometry, we only care about the molecules. The electron geometry, we care about the electrons and the molecules. So it's tetrahedral because you can think there's a lone pair or electron cloud here, and then there's one like going back out here on the other side. And it's a tetrahedral type structure. So that is water in a nutshell. That's what water looks like. Tetrahedral, lone pairs on top, just like that, pushing the hydrogens down. So let's do another example. Let's do formaldehyde. I'll leave it at this. Hopefully you get the point from this, from just doing formaldehyde. Being able to do these shapes, these are easy ones. I know there's a lot harder ones like seesaw and trigonal pyramid and antiprismatic, and there's a whole bunch of different molecular shapes. Unfortunately, the best way to know those ones is to memorize them. There's probably a table in your book, or there's plenty of sources online. Just note cards. I highly encourage note cards. You can flip through them in between classes and whatnot. So let's do one more, formaldehyde. So formaldehyde is it's actually the simplest ketone. So let's go ahead. It is the structure, or the formula is CH2O, just like that. So so CH2O. So this one is, let's say, this was tricky. It's like, well, which is the central atom? Is it the oxygen or is it the carbon? It's definitely not going to be the hydrogen. You don't really ever have to worry about the hydrogen. Actually, you don't have to worry about the hydrogen being a central atom. Period. Take my word for it. I'll tell you that for free. You just won't. Hydrogen can't sustain having more than one thing bonded to it unless it's in a pseudo bond, like a hydrogen bonding circumstance or whatnot. But usually it's not fully bonded to two things at once. Anyways, so in this instance, it is a little tricky to be able to determine what is going to be bonded to, what's the central atom. Well, we know that carbon loves to have 4 bonds. In fact, it pretty much needs 4 bonds. It will always need 4 bonds, or enough electrons to sustain it. So let's just say carbon in most circumstances will be a central atom, a big time central atom player. So let's go ahead and write that. We have a carbon here. Now let's go ahead and attach our O, and then let's attach our hydrogens. Okay, so I know I've got 3 things attached, so I'm going to try and keep them all equally spread apart as best I can, because, that's probably how they're most likely going to be. Now, oh crap, we didn't look up how many valence electrons. So carbon has 4, the 2 hydrogens have 2 plus 6, so that's going to be 12, right? Okay, now we're good. 12 electrons to deal with. We just got rid of 6 of them. 1, 2, 3, 4, 5, 6. So we're down to 6 left. Well, we need to put them on the atoms not considered to be the central atom. So in that case, the hydrogens or the oxygen. Well, we know we can't put any electrons on hydrogen, so we won't do that. So instead, we'll put all 6 of them on the oxygen. Well, if you notice, that works, and we've gotten rid of all of our electrons. That's fine and dandy, but this carbon is unsatisfied. It does not like to have this vacancy. In fact, it's got a positive charge, and this has actually got a negative charge, which is just due to the formal charges, which you can calculate that. And there's a nice little way to do that in your textbook. But this is unfavorable because of these charge separations. It does help us be able to predict the polarity pretty nicely, but it's not a major contributor to the structure. So how we would actually write this is we would say carbon in the center, hydrogens, oxygen, but instead of writing all these, we're going to put another double bond right here. So it's double bond O, and then we're just going to have 2 electrons, or 4 electrons on that oxygen, just like that. Now the carbon has 4 bonds, 1, 2, 3, 4, so it's satisfied. The oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, so it's satisfied. Everything is happy. Everything's got its octet, except for the hydrogens, which will never have an octet because they don't need it. It just needs 2. Everything is happy. This is your Lewis structure. So, all right, you guys, I want to leave this one here because I don't want to waste too much of time. There's other videos for me to make for you guys and other things for you guys to do, and I know you don't like long videos anyways. So, hope this helps. If you have any questions, please let me know. I do notice that the most common mistake people make is this step right here, getting the correct number of valence electrons. If you don't have the correct number of valence electrons, you will make a mistake every time, obviously, because it won't be right. But watch out for these charge separations, and make sure that you are writing in correct number of bonds to everything. So, all right, you guys, subscribe. Please hit that like rating if this helped. It really, really, really helps me out if you hit a like rating. If you hit that little thumbs up button, it really helps me out if you do that. So leave a comment, subscribe, tell your friends to check out my page. There's going to be a lot of cool stuff. I uploaded a video about me talking about it. So stay tuned. It's going to be great. This next few weeks are going to be pretty epic, and I can't wait. So have a good night, you guys. I will talk to you later, and I'll see some of you very soon. Bye.